Amazon's real business isn't online shopping. Google's real business isn't search. The single biggest profit engine sitting inside these companies comes from something you'll never actually see, something that runs quietly in the background every single time you open an app, stream a show, or ask an AI chatbot a question. Most people assume Amazon makes its money selling products, that Google makes its money from ads alone, that Microsoft makes its money from Windows licenses. And yes, those businesses matter. But underneath all of that, there's a second business that most people barely think about. It turns out to be so profitable that it quietly became the financial backbone of some of the biggest companies on Earth. Today, we're going to slow down and actually understand this business from the ground up. Not with jargon, not with confusing finance terms thrown at you without explanation, but in plain language, the way you'd explain it to a friend over coffee. By the end of this, you'll understand exactly what the cloud is, why it turned into one of the most profitable business models in modern history, how three companies ended up dominating it, and why right now, in this exact moment, they're pouring more money into it than almost any other bet they've ever made. Let's start with the most basic question, because honestly, most people never actually stop to ask it. What is the cloud, physically? If you picture it as some kind of invisible, magical internet dimension, where your photos and files just float around in the sky, you're not alone. A lot of people picture it that way, mostly because the word itself was chosen to sound soft and abstract and non-technical. But the truth is far more physical and far more interesting. The cloud is buildings, actual buildings, sitting in specific locations around the world, filled with racks and racks of computers. These buildings are called data centers, and some of them are absolutely massive, some the size of several football fields put together, filled with thousands upon thousands of individual servers stacked floor to ceiling in long rows. Inside these buildings, massive cooling systems run nonstop, 24 hours a day, all year round, because all those servers generate enormous amounts of heat, and if that heat isn't managed properly, the machines fail. There are backup power generators in case the electricity grid goes down. There are armed security guards and biometric access systems because these buildings hold enormously valuable data. There are redundant internet connections running in from multiple directions, so that if one cable gets cut, the building doesn't go offline. All of this exists so that when you open Netflix and press play, or when you type something into Google search, or when you back up your phone's photos, the actual work of storing and processing that information happens inside one of these physical buildings, somewhere in the world, and gets sent back to your device over the internet in a fraction of a second. That's it, cloud. It's not magic. It's just somebody else's computer sitting in a warehouse that you're renting access to. Now here's where it gets interesting, because the natural next question is, well, who builds these things and who pays for them? And the answer takes us back to a story that most people don't know, which is that the biggest cloud company in the world today, Amazon Web Services, wasn't originally planned as a business at all. It came out of Amazon solving its own internal headache. Back in the early 2000s, Amazon was still primarily known as an online bookstore that had expanded into selling other products. Internally, their engineering teams kept running into the same frustrating problem over and over again. Every time a new project needed to be built, whether it was a new feature for the website or some internal tool, the engineers had to build the same basic infrastructure from scratch. They needed storage space to hold data. They needed computing power to run calculations. They needed databases to organize information. And instead of reusing existing systems, teams kept rebuilding these same foundational pieces again and again, wasting enormous amounts of time and money in the process. At some point, Amazon's leadership realized this was insane. Why should every single team inside the company reinvent the wheel every time they wanted to launch something new? So they made the decision to build a standardized internal set of tools, shared foundation, that any team inside Amazon could plug into instead of building their own version from scratch. This internal system worked so well that it solved a huge amount of wasted effort and dramatically sped up how fast Amazon could build new products. And then somebody inside Amazon had an idea that, at the time, sounded almost strange. If this internal infrastructure was this useful for Amazon's own teams, what if other companies, completely outside of Amazon, could rent access to the exact same infrastructure? What if a small startup that couldn't afford to build its own data center could instead just rent computing power and storage from Amazon, paying only for what they actually used? In 2006, Amazon officially launched this idea to the public under the name Amazon Web Services, or AWS, and it changed everything. Suddenly, Two-person startup working out of someone's garage could access the exact same caliber of computing infrastructure that a massive corporation would use, without spending millions of dollars building it themselves. They could just rent it, scale it up when they needed more, scale it down when they needed less, and only pay for actual usage. This was revolutionary because it completely removed one of the biggest barriers to starting a tech company. Before this, if you wanted to build an app or a website that could handle a large number of users, you needed serious capital just to buy servers and set up your own infrastructure before you'd even proven your idea worked. After AWS existed, you could start building immediately, with almost no upfront cost and only pay more as your business actually grew. This is a huge part of why the 2010s saw such an explosion of new tech startups. The cost of getting started dropped dramatically, and a huge amount of that drop came directly from the existence of cloud computing. Fast forward to today, and AWS isn't some side project anymore, it's an enormous, wildly profitable business. In fact, AWS generates a disproportionately large share of Amazon's total operating profit, even though most people still think of Amazon primarily as a shopping website. That's the part that surprises people the most when they first hear it. Amazon's retail business, shopping website that most of us use, actually runs on thin margins. Selling physical products is a low-margin business. There's a lot of competition, a lot of logistics costs, a lot of complexity in shipping and warehousing. But AWS, the cloud computing side of the business, runs on a completely different level of profitability. So in a very real sense, when people say Amazon is one of the most valuable companies in the world, a huge part of that value comes not from the shopping cart you use, but from a business that most customers never directly interact with or even think about. So now let's get into the actual economics of why this business is so profitable, because this is really the heart of the whole story. The core idea is something economists call economies of scale, and it's actually pretty simple to understand once you see it laid out. Imagine you're a single company and you decide you want to build your own private data center just for your own use. You'd need to buy servers, you'd need cooling systems, you'd need backup power, you'd need networking equipment, you'd need staff to maintain all of it, and you'd need physical space to house it all. All of this is enormously expensive when you're doing it at a small scale, just for yourself. The cost per unit of computing power you get out of that investment is extremely high, because you're not able to spread that cost across very many users. Now imagine instead that you're Amazon or Google or Microsoft, and instead of building infrastructure for just yourself, you're building it at a scale large enough to serve millions of customers simultaneously. When you're buying servers, you're not buying 10 of them, you're buying hundreds of thousands of them at massive volume discounts that a small company could never access. When you're negotiating for electricity, you're negotiating industrial scale contracts that bring the price per unit of power down significantly. When you're building the physical data center itself, you're spreading that enormous fixed cost across an enormous number of paying customers, which means the cost per customer keeps shrinking as more customers use the system. It's the fundamental engine behind why cloud computing is so profitable. The company's cost to deliver 1 unit of computing power keeps dropping as they scale up, but the price they charge customers doesn't need to drop nearly as fast. Because for the customer, the alternative isn't a cheaper option. The alternative is building their own infrastructure from scratch, which is far more expensive than just paying the cloud provider. That gap between what it actually costs the cloud company to deliver the service and what they charge customers for it is where the profit lives. And that gap tends to be very healthy. Publicly available financial reports show that AWS typically operates with an operating margin somewhere in the range of 25 to 35%, which is an extraordinarily high margin for a business of this size, especially when you compare it to Amazon's retail business, which typically operates on margins in the low single digits. This difference in profitability is exactly why, even though most people associate Amazon with online shopping, the actual financial engine underneath the company runs largely on cloud computing. But there's another layer to this story that's just as important, and it's something most people never think about, which is the pricing model itself. Cloud computing typically works on what's called a pay-as-you-go model, sometimes also described as a utility model, similar in some ways to how you pay for electricity or water. Instead of paying a large upfront cost to buy your own servers, pay based on how much computing power, storage, or data transfer you actually use during a given period. If your usage goes up because your app suddenly gets more users, your bill goes up. If your usage goes down, your bill goes down. This sounds like a small detail, fundamentally changes the economics of building a business. It converts what used to be a massive upfront capital expense into a smaller, ongoing operating expense that scales naturally with your actual business growth. For startups especially, this was transformative because it meant you didn't need millions of dollars in funding just to get your infrastructure off the ground before you'd even proven whether your product would work. You could start small, prove out your idea, and only pay more as you actually grew. For the cloud companies themselves, this pricing model creates an extremely attractive business dynamic because it means customers naturally spend more as their businesses succeed. A startup that starts out paying a few $100s a month eventually grows into a massive company processing enormous amounts of data. Their cloud bill scales up right alongside them, sometimes into the millions of dollars per year. Cloud provider essentially grows in lockstep with the success of every company built on top of their platform, which means that a portfolio of thousands of customers, some small and some enormous, produces a stable and growing stream of revenue over time. Now, here's a part of this story that doesn't get talked about nearly enough. And it's honestly one of the most important pieces of the entire puzzle, which is something called vendor lock-in. When a company builds its entire technical infrastructure on top of a specific cloud provider, let's say they build all their databases, their applications, their internal tools, all of it running on AWS, something interesting happens over time. It becomes extremely difficult and expensive for that company to switch to a different cloud provider later on, even if a competitor offers slightly better pricing or slightly better technology. Why? Switching cloud providers isn't like switching from one grocery store to another. It means rebuilding significant parts of your technical systems to work with a different provider's specific tools and services, which are often not directly compatible with each other. It means months of engineering time spent on migration instead of building new features for your actual product. It means risk, because moving critical systems from one provider to another can introduce bugs, downtime, or data loss if not done extremely carefully. For a small company, this might mean weeks of disruption. For a large company running mission-critical systems, it can mean months of careful, expensive migration work, sometimes costing millions of dollars in engineering time alone. Because of this, once a company commits to a cloud provider and builds a significant amount of its infrastructure on top of it, they tend to stay with that provider for years, even if better options exist elsewhere. This creates what's sometimes described as a moat around these cloud businesses, a kind of built-in customer retention that doesn't require constant marketing or sales effort to maintain. It's not that customers are forced to stay. Technically, they could leave at any time. But the practical cost and risk of leaving is high enough that most companies simply don't bother, especially when the existing provider continues to offer reliable service. Dynamic gives cloud companies something incredibly valuable in business terms, which is predictable, recurring revenue that tends to grow over time rather than shrink. Because customers rarely leave and their usage tends to increase as their own businesses grow. Now let's zoom out and talk about the competitive landscape. Because cloud computing isn't a monopoly, it's a fierce three-way battle between Amazon, Microsoft, and Google, with a handful of smaller players also competing for pieces of the market. Amazon Web Services holds the position of market leader, largely because they got there first, launching all the way back in 2006, while competitors were still years away from taking cloud computing seriously. That early mover advantage gave AWS years of head start in building out infrastructure, developing services, and signing up customers before anyone else was even competing in the space. As of recent years, AWS typically holds somewhere around 30% of the global cloud infrastructure market, making it the single largest player, though its share has gradually declined slightly over time as competitors have caught up. Microsoft Azure sits in second place, grown remarkably quickly, largely because Microsoft had something none of its competitors had: decades of deep relationships with enterprise businesses through products like Windows, Office, and various business software tools. When a massive corporation has already been running on Microsoft products for 20 years, choosing Azure as their cloud provider feels like a natural, low-friction extension of a relationship that already exists, rather than starting fresh with an unfamiliar company. Existing trust and existing infrastructure gave Microsoft a significant advantage in winning over large established businesses, even though they entered the cloud market later than Amazon did. Azure currently holds somewhere in the range of 20% of the global market, and its growth rate has often outpaced AWS in recent years, meaning the gap between the two companies has been gradually narrowing. Google Cloud sits in third place, generally holding somewhere around 10 to 12% of the global market. Google entered the cloud market later than both of its competitors and has historically struggled to catch up in terms of raw market share. Google's competitive advantage lies somewhere else entirely, in artificial intelligence and data processing technology. Google has spent over a decade building some of the most advanced machine learning and data infrastructure in the world, originally to power its own search engine, its advertising business, and products like Google Maps and YouTube. Now, as the entire tech industry has shifted its attention toward artificial intelligence, Google Cloud has positioned itself as offering some of the most advanced AI tools and infrastructure available to any business willing to build on their platform. Beyond these three giants, there are smaller players like Oracle Cloud, IBM Cloud, and Alibaba Cloud, each carving out smaller niches, often focused on specific industries or specific regions of the world. But none of them come close to challenging the dominance of the big three. This three-way competition matters enormously. Even a small shift in market share between these companies translates into billions of dollars of revenue. If Google Cloud manages to grow its market share by even a couple of percentage points, that represents an enormous amount of additional revenue given how massive the overall cloud computing market has become. This is why these companies constantly compete on price, constantly release new features, constantly try to lock in new large enterprise customers with long-term contracts and discounts. It's also why you'll often hear about price wars in cloud computing, where one provider lowers prices on certain services, prompting the others to respond with similar cuts, all in an effort to win over cost-sensitive customers without giving up too much profitability in the process. Now, let's talk about the part of this story that's happening right now, in real time, which is the impact of artificial intelligence on the entire cloud computing industry. If you've been paying any attention to tech news over the past couple of years, you've probably heard about the enormous amounts of money being spent on AI infrastructure, sometimes described using numbers so large they almost don't feel real. Hundreds of billions of dollars committed to building new data centers specifically designed for AI workloads. To understand why this is happening, you need to understand something important about how AI models actually work. Training a large AI model, the kind that powers tools like advanced chatbots or image generators, requires an absolutely staggering amount of computing power, far beyond what a typical website or app would ever need. These AI models are trained by processing enormous amounts of data, running complex mathematical calculations across specialized computer chips, often for weeks or even months at a time, using thousands of these specialized chips working together simultaneously. Even after a model is trained, actually running it to answer questions or generate content, something called inference, also requires significant computing power every single time someone uses it. Multiply that by millions of people using these AI tools every single day, and you start to understand why the demand for computing power has exploded so dramatically. This is exactly why cloud computing and artificial intelligence have become so deeply intertwined. Building the kind of specialized infrastructure needed to train and run large AI models isn't something most individual companies can do on their own. It requires massive capital investment, specialized hardware, and deep technical expertise. Companies that want to build AI products increasingly turn to the same big three cloud providers, renting access to specialized AI computing infrastructure rather than trying to build it themselves. This has created an entirely new wave of demand for cloud services, on top of everything that already existed before AI became such a major focus. And because this demand is so significant, and because being the preferred infrastructure provider for the AI industry represents such an enormous business opportunity, Amazon, Google, and Microsoft have all dramatically increased how much they're investing in new data centers, specifically ones equipped with the kind of specialized chips needed for AI workloads. This is why, if you look at these companies' financial reports in recent times, you'll see capital expenditure numbers that are genuinely staggering. Tens of billions of dollars being spent by a single company in a single quarter, largely going toward building new data centers and buying enormous quantities of specialized computing chips. Some of this spending goes toward buying chips from companies that specialize in designing this kind of hardware. While some of these cloud giants have also started designing their own custom chips, specifically optimized for AI workloads, in an effort to reduce their dependency on outside suppliers and to gain a competitive edge in terms of performance and cost efficiency. This is a genuinely enormous bet these companies are making, essentially wagering that the demand for AI computing power is going to keep growing for years to come, and that whichever company builds the best, most efficient infrastructure to support that demand will end up capturing an enormous share of the value created by the entire AI industry moving forward. It's worth remembering that this is essentially the same fundamental bet Amazon made back in 2006 when almost nobody else was taking cloud computing seriously, just applied to an even bigger opportunity and an even larger scale of investment. Also worth understanding a little bit about the physical and environmental side of all this. Because building data centers at this scale isn't just a financial story, it's also a story about electricity, land, and natural resources. Data centers consume enormous amounts of electricity, and that consumption has been growing rapidly as AI workloads increase. This has led these companies to sign massive long-term contracts for renewable energy, and in some cases, explore more unconventional options like investing in nuclear power, specifically to guarantee they'll have enough reliable electricity to power their growing data center operations for decades to come. Cooling these facilities also requires enormous amounts of water in many cases, which has raised questions and concerns in some of the communities where these data centers are being built, especially in regions already dealing with water scarcity. Choosing where to physically build a new data center has become its own complex strategic decision, involving questions about electricity availability, water access, climate, land cost, local regulations, proximity to the populations that will actually be using the services powered by that facility. This is part of why you'll often hear about massive new data center construction projects being announced in specific states or countries, because these companies are essentially racing to secure the physical locations and infrastructure needed to support this next wave of growth before their competitors do. There's also an important layer to this story around what's sometimes called sovereign cloud or regional infrastructure. As cloud computing has become critical infrastructure for entire economies, governments around the world have started paying much closer attention to where their data is actually being stored and processed. Many countries now have regulations requiring that certain types of sensitive data, particularly around government services, healthcare, or finance, be stored within that country's own borders rather than in a data center located somewhere else in the world. This has pushed the big cloud providers to build out regional infrastructure in many different countries, not just for performance reasons, making services faster for local users, but also for regulatory and political reasons, allowing them to offer services that comply with local data sovereignty laws. This adds yet another layer of complexity and expense to running a global cloud business. Instead of just building a handful of massive data centers in a few strategic locations, these companies increasingly need to build infrastructure spread across dozens of countries and regions around the world. Let's also talk briefly about who actually uses these cloud services, because it's a much wider range of customers than most people realize. On one end, you have small startups running their entire business on cloud infrastructure because it lets them avoid the upfront cost of building their own systems. On the other end, you have some of the largest companies in the world running significant portions of their operations on top of these cloud platforms as well. Companies you might not expect, banks, hospitals, government agencies, media companies, all of them increasingly rely on cloud infrastructure rather than maintaining their own private data centers, because the economics of building and maintaining your own infrastructure simply don't make sense anymore for most organizations, given how efficiently the big cloud providers can deliver the same capability at a fraction of the cost. Even companies that compete directly with Amazon in other areas of business still often choose to run parts of their infrastructure on AWS, because the cost and reliability advantages are significant enough to outweigh any discomfort about paying a competitor for infrastructure services. It's also worth understanding that many companies today don't rely on just a single cloud provider, instead use what's called a multi-cloud strategy, spreading their infrastructure across 2 or even 3 different cloud providers simultaneously. There are a few reasons companies do this. Sometimes it's about avoiding being too dependent on a single provider, reducing the risk that comes with vendor lock-in that we talked about earlier. Sometimes it's about taking advantage of specific strengths that different providers offer, maybe using Google Cloud specifically for certain AI or data-related workloads, while using AWS for other parts of their infrastructure. And sometimes it's simply about negotiating leverage. Having the technical ability to move workloads to a different provider gives a company more bargaining power when negotiating pricing and contract terms. This multi-cloud trend has become increasingly common among larger enterprises, even though it does add additional complexity to managing their technical systems. Now, stepping back from all of this detail, it's worth asking the bigger picture question. Why does any of this actually matter to you? Someone who probably isn't running a massive tech company or making decisions about billion-dollar data center investments. The answer is that this business model, quietly running in the background of the internet, actually shapes an enormous amount of the world around you, even if you never think about it directly. Every app on your phone, every website you visit, every AI tool you interact with, all of it is built on top of this infrastructure. The price you pay for subscriptions, speed at which apps load, the reliability of services you depend on every day, all of it is connected to decisions being made inside these massive cloud businesses. When these companies invest hundreds of billions of dollars into new infrastructure, that investment eventually shapes what kinds of products and services become possible in the years ahead. What new AI tools get built, how fast they improve, and how widely available they become to regular people and small businesses, not just huge corporations with massive budgets. Understanding this business model gives you a much clearer lens for understanding why certain tech trends happen the way they do, why certain companies suddenly announce massive spending increases, why prices for certain digital services change over time, and why competition between these tech giants keeps intensifying rather than settling down. There's also a broader lesson buried inside this story about how massive, durable businesses often get built. Amazon didn't set out with some grand master plan to dominate cloud computing from day one. They built something to solve their own internal problem, realized it had value beyond their own walls, and turned it into a business almost as an afterthought. That original decision, made back in the mid-2000s, ended up becoming one of the most valuable business decisions in modern corporate history. It's a reminder that some of the biggest opportunities in business don't always come from some brilliant, obvious idea dreamed up in a boardroom. Sometimes they come from solving a real, practical problem, well enough that other people want the same solution for themselves. Google and Microsoft, watching Amazon's success, eventually built their own competing versions of the same idea. Leveraging their own existing strengths, Google's expertise in data and artificial intelligence, Microsoft's deep enterprise relationships, to carve out their own significant slices of an enormous and rapidly growing market. Let's go back even further in time for a moment, because understanding what came before the cloud actually makes it much easier to appreciate just how big a shift this really was. Before cloud computing existed as a mainstream option, if you wanted to run any kind of website or software product, you had basically two choices, and neither of them was particularly good for a small company or a new idea still trying to prove itself. The first option was to buy your own physical servers, set them up in your own office or a rented space, and manage everything yourself, from the hardware to the software to the internet, connection to the electricity and cooling. This was called on-premise infrastructure, and it was expensive, slow to set up, and required specialized technical staff just to keep everything running. If your business suddenly got popular and needed more computing power, you couldn't just flip a switch. You had to physically buy more servers, wait for them to be delivered, install them, and configure them, a process that could take weeks or even months. If your business slowed down, you were still stuck paying for all that expensive hardware sitting there, mostly unused. Second option was to rent space and equipment in a third-party facility, sometimes called co-location, which was slightly more flexible but still required significant upfront investment and long-term contracts, still didn't solve the fundamental problem of scaling up or down quickly based on actual need. This meant that starting any kind of ambitious tech company required serious capital just to get the basic infrastructure in place, long before you'd even figured out if customers actually wanted what you were building. This is part of why, before cloud computing became widely available, launching a tech startup was a much more capital-intensive endeavor, often requiring wealthy backers or significant loans just to cover the cost of servers and infrastructure before a single customer had even signed up. Cloud computing completely flipped this equation. Instead of a large upfront capital expense, something accountants generally refer to as capital expenditure or CapEx, cloud computing turned infrastructure into an ongoing operating expense, or OpEx, something you pay for gradually as you actually use it. Similar to a monthly utility bill, distinction matters enormously in business, not just practically but financially as well. Because large upfront capital expenses tie up cash and create financial risk, while smaller ongoing operating expenses that scale with actual revenue are generally much easier for a growing business to manage. Shift is a big part of why so many successful tech companies from the past 15 years or so were able to get off the ground with relatively modest amounts of initial funding compared to tech companies from earlier eras The cost of actually building and running their technology dropped so dramatically once cloud computing became widely available. It's worth walking through a few real-world examples to make this a little more concrete, because it's easy for all of this to sound abstract until you connect it to services you actually use every day. Take Netflix, for example, a company that streams video to hundreds of millions of people simultaneously around the world. Netflix doesn't own or operate its own data centers for delivering that streaming content. Instead, they run almost their entire infrastructure on top of Amazon Web Services. Think about what that actually means. One of the largest entertainment companies in the world, delivering video to an enormous global audience, doesn't own the physical infrastructure that makes any of it possible. They're renting it at massive scale from Amazon. Arrangement allows Netflix to focus their engineering resources on building a great streaming product and recommendation system, rather than spending enormous amounts of time and money managing physical servers and data centers themselves. Or consider a company like Spotify, which for a long time built much of its infrastructure on Google Cloud, taking advantage of Google's strength in data processing and analytics to power things like personalized playlists and music recommendations. Airbnb is another well-known example of a company that scaled its entire global platform on top of cloud infrastructure rather than building its own. These aren't small examples either. These are companies serving hundreds of millions of users, and none of them needed to build their own physical data centers to get there. This really illustrates just how transformative this shift has been, allowing companies to reach massive global scale while focusing their own resources and expertise on their actual product, rather than the underlying infrastructure required to deliver it. There's another piece of this puzzle worth understanding, which is something called the shared responsibility model, because it explains an important nuance in how security and reliability actually work in cloud computing. When a company uses a cloud provider, the cloud provider is generally responsible for the security and reliability of the underlying infrastructure itself, local servers, the data centers, the networking equipment, making sure all of that is protected, maintained, and kept running reliably. But the customer using that infrastructure is generally still responsible for how they configure and use it, making sure their own applications are built securely, that access permissions are set up correctly, and that their own data is handled properly. Division of responsibility is actually one of the reasons cloud computing can be extremely secure and reliable when used correctly, because the cloud provider is investing enormous resources into physical and infrastructure level security that would be almost impossible for an individual company to replicate on their own, while still leaving enough flexibility for each customer to configure things according to their own specific needs. At the same time, this also means that security failures do happen when customers misconfigure their own systems, which is actually one of the more common causes of data breaches involving cloud infrastructure, not because the underlying cloud platform itself was insecure, but because whoever set it up made a mistake in how they configured access permissions or data protection settings. It's also worth spending a moment on how pricing actually works in more detail, because the pay-as-you-go model we talked about earlier is really just the starting point. Cloud providers offer many different pricing structures designed to fit different kinds of usage patterns. For companies with predictable, steady workloads, cloud providers often offer discounted pricing in exchange for committing to a certain amount of usage over a longer period of time, sometimes called reserved pricing, which can lower costs significantly compared to standard pay-as-you-go rates. For workloads that are flexible and can be interrupted without causing problems, cloud providers sometimes offer spare, unused computing capacity at steep discounts, since it's essentially capacity that would otherwise sit idle. Creates a fairly sophisticated pricing ecosystem, where sophisticated customers who understand how to structure their usage can significantly reduce their cloud costs, while customers who simply use default, standard pricing options end up paying considerably more for the exact same underlying resources. This has actually given rise to an entire specialized industry, sometimes referred to as cloud cost optimization, or more formally, FinOps, where companies and consultants specialize specifically in helping other businesses reduce their cloud spending by better understanding and optimizing how they use these complex pricing structures. Good example of just how large and complex this entire industry has become, to the point where managing your cloud bill effectively has become its own specialized discipline within many companies. Another important trend worth understanding is something called serverless computing, which represents a further evolution of the same underlying idea we've been discussing throughout this entire video. In the earliest days of cloud computing, customers were essentially renting virtual versions of physical servers, still needing to think about how many servers they needed and how powerful each one should be. Serverless computing takes this abstraction even further, allowing developers to simply write code and have the cloud provider automatically handle running that code whenever it's needed, without the developer ever having to think about servers at all, hence the name. This might sound like a small technical detail, but it represents the continuing trend of cloud providers absorbing more and more of the underlying complexity of running software, allowing their customers to focus even more narrowly on just building their actual product. Each step in this evolution, from renting physical space in a data center, to renting virtual servers, to now not even thinking about servers at all, represents cloud providers taking on more responsibility and more of the underlying complexity. Naturally also means capturing more of the value and more of the revenue in the process. It's also worth touching on the chip side of this story a bit more, because it's become an increasingly important competitive battleground, especially with the rise of artificial intelligence. For years, most of the specialized computer chips needed to train and run large AI models came from outside chip manufacturers, companies that specialize specifically in designing this kind of high-performance hardware. Increasingly, the big cloud providers have started designing their own custom chips specifically optimized for their own infrastructure and their own customers' needs. Amazon has developed its own custom-designed chips for both general computing and AI-specific workloads. Google has developed its own specialized AI chips that power much of its own internal AI research, as well as services offered to Google Cloud to customers. Microsoft has also begun developing its own custom silicon for similar reasons. The motivation behind this is fairly straightforward. By designing their own chips, rather than relying entirely on outside suppliers, these companies can potentially reduce costs, improve performance for their specific use cases, and reduce their dependency on external chip manufacturers, who themselves face enormous demand from multiple competing customers simultaneously. Chip strategy has become such an important part of the competitive landscape that it's now considered one of the key differentiators between the major cloud providers, not just in terms of cost, but in terms of how well each provider's infrastructure performs specifically for the kind of demanding AI workloads that are driving so much of the current growth in this industry. There's also a fascinating and often overlooked physical layer to all of this, involving how these data centers actually connect to each other and to the rest of the world, which involves an enormous global network of undersea fiber optic cables running along ocean floors, connecting continents together. When you access a cloud service, your request might travel through several different data centers and network connections before reaching its final destination. And increasingly, the major cloud providers have started investing directly in building and owning these undersea cables themselves, rather than simply relying on cables owned by traditional telecommunications companies. Might sound like an unusual business for a cloud computing company to be involved in, but it makes sense once you understand that reliable, fast, high-capacity network connections between different parts of the world are just as critical to running a global cloud business as the data centers themselves. If a cloud provider doesn't have reliable, fast network connections between their various data centers around the world, they can't offer the kind of consistent, reliable service that their customers depend on. So investing directly in this underlying network infrastructure has become another way these companies are working to control more and more of the entire technology stack that makes their business possible. It's worth also addressing some of the criticism and concerns that have come up around this industry, because it's not a story without controversy. As these three companies have grown to dominate such a critical piece of global technology infrastructure, questions have increasingly been raised about market concentration and competition. Regulators and lawmakers in various countries have started examining whether having such a small number of companies control such a critical piece of infrastructure creates risks, both in terms of fair competition for smaller companies trying to compete, and in terms of what happens if one of these massive providers experiences a significant outage or failure, given how many other businesses and services now depend on their infrastructure to function. There have been real-world examples of major cloud outages causing widespread disruption across many different websites and services simultaneously, simply because so many different companies happen to rely on the same underlying cloud provider. This has led to ongoing conversations within the industry about the importance of redundancy and not relying too heavily on a single provider, part of what's driving the multi-cloud trend we discussed earlier. There are also broader questions being asked about environmental impact. Given how much electricity and water these data centers consume, questions that have become even more pressing as AI-driven demand for computing power continues to grow rapidly. These are legitimate concerns that continue to shape ongoing conversations about regulation, sustainability, and competition within this industry, even as the underlying business itself continues to grow at a remarkable pace. Looking toward the future, it's worth thinking about where this story goes from here. Current wave of massive investment into AI-focused data center infrastructure represents a genuine bet by these companies that artificial intelligence is going to become deeply embedded into how businesses and individuals use technology for years to come. That bet turns out to be correct. The companies that have built the best, most efficient infrastructure to support that demand stand to capture an enormous amount of value from that shift. At the same time, this represents a significant financial risk as well, given the sheer scale of money being invested. If demand for AI computing doesn't grow as quickly as expected, or if more efficient ways of training and running AI models emerge that require significantly less computing power than currently assumed, companies could find themselves having built far more infrastructure than they actually need, representing a significant financial miscalculation. This is part of why, even as these companies continue to announce enormous new investments, ongoing debate within the industry and among investors about whether the pace of this spending is sustainable, or whether it represents a level of investment that's outpacing actual proven demand. Regardless of how that particular question plays out, the underlying business model we've spent this entire video breaking down, massive scale infrastructure, rented out to customers who would otherwise have to build it themselves, protected by the natural stickiness of vendor lock-in, continuously reinforced by ever-growing demand for computing power, has proven itself to be one of the most durable and profitable business models to emerge from the technology industry in the past 2 decades, and there's little reason to think that's going to change anytime soon. There's another dimension to this story worth exploring, which is how this entire industry has reshaped careers and the broader technology job market. Cloud computing became the dominant way of building and running software. An entirely new category of specialized jobs emerged around it. Cloud architects, people who specialize in designing how a company's infrastructure should be structured across one of these platforms, became highly sought-after roles commanding significant salaries. Certifications offered directly by Amazon, Google, and Microsoft, proving that an individual has deep expertise in their specific cloud platform, became valuable credentials in the job market, with many professionals investing significant time and money into earning these certifications to make themselves more competitive for jobs. Higher consulting industries emerged specifically to help companies migrate their existing systems onto cloud platforms, a process that, for large established companies with decades of existing technology, can be an enormously complex, multi-year undertaking requiring specialized expertise. This migration work alone has become a massive business in its own right, with major consulting firms building entire divisions specifically focused on helping companies move from older on-premise systems onto modern cloud infrastructure. At the same time, the rise of cloud computing has also changed what kinds of technical skills are considered valuable. Where once being able to physically set up and maintain servers was a core skill for many technology professionals, a particular skill set has become less central for many roles, replaced instead by the ability to effectively use and configure cloud services, write code that takes advantage of cloud-specific features, understand how to manage costs and security within these complex cloud environments. This shift has been significant enough that it's fundamentally changed what technology education and training programs focus on teaching cloud computing skills now considered essential knowledge for many technology careers that might not have required this kind of knowledge just 15 or 20 years ago. It's also worth understanding the geopolitical dimension of this story, because as cloud computing has become such critical infrastructure, it's increasingly become intertwined with international politics and national security considerations. Governments around the world have started thinking about cloud computing infrastructure the same way they think about other critical infrastructure like power grids or transportation networks, recognizing that a country's economy and even its national security can become dependent on infrastructure that might be controlled by companies based in a different country entirely. This led some countries to invest in building their own domestic cloud computing capabilities, specifically to reduce dependency on American companies like Amazon, Google, and Microsoft. China, for example, has developed its own major cloud computing companies, largely because of both business opportunity and a desire to maintain technological independence from American infrastructure. The European Union has had ongoing discussions and policy initiatives around digital sovereignty, exploring ways to reduce European dependency on American cloud providers for sensitive government and business data. These conversations have become even more pressing, as artificial intelligence has become such a strategically important technology, with many governments now viewing leadership in AI infrastructure as directly connected to broader questions of economic competitiveness and national security in the years ahead. Geopolitical layer adds yet another dimension of complexity and importance to what might otherwise seem like a purely business-focused story about server farms and computing infrastructure. There's one more important thread worth pulling on here, is how this entire industry has changed the relationship between big established companies and small ambitious startups. Before cloud computing existed at scale, large established companies had a significant structural advantage over smaller competitors simply because they had the capital to build expensive infrastructure that smaller companies couldn't afford. Cloud computing dramatically leveled this particular playing field, allowing a small startup with limited funding to access essentially the same caliber of computing infrastructure as a massive corporation, paying only for what they actually used rather than needing enormous upfront investment. Has been credited as one of the significant factors behind the explosion of new technology startups over the past 15 years, because the barrier to actually building and launching a new digital product dropped so significantly. At the same time, there's an interesting irony buried inside this story, because even as cloud computing helped level the playing field between big and small companies in terms of access to infrastructure, it also created a new kind of dependency where an enormous number of these same startups and smaller companies now rely entirely on infrastructure controlled by just 3 or 4 massive companies. In a sense, cloud computing removed one kind of competitive advantage that big companies used to hold, the ability to afford expensive infrastructure, while creating an entirely new dynamic where a small number of infrastructure providers now hold significant influence over huge portions of the broader technology industry, simply because so much of that industry now runs on top of their platforms. So to bring everything together, here's the full picture. The cloud isn't some abstract, invisible internet concept. It's physical infrastructure, buildings filled with servers, consuming enormous amounts of electricity, built and maintained by a small handful of massive technology companies. Amazon essentially invented this business almost by accident, turning an internal engineering solution into what eventually became the most profitable part of the entire company. The profitability of this business comes down to a straightforward but powerful economic principle: economies of scale, where massive investment allows these companies to deliver computing power at a lower cost than almost any individual company could achieve on their own, while still charging customers a healthy margin above that cost. Customers build their systems on top of one of these platforms, switching becomes difficult and expensive, creating long-term, sticky, recurring revenue that keeps growing as customers' own businesses grow. 3 companies, Amazon, Microsoft, and Google, dominate this market, each competing fiercely while leveraging their own unique strengths. And now the explosion of artificial intelligence has added an entirely new, massive wave of demand on top of everything that came before, pushing these companies to invest at a scale the world has genuinely never seen before in this industry. This entire story, from a warehouse full of humming servers to trillion-dollar companies, is a masterclass in how a boring-sounding piece of technical infrastructure, something most people never think twice about, quietly became one of the most powerful and profitable business models of the modern era. And based on everything happening right now with artificial intelligence, it looks like this story is really only just getting started. What makes this whole story genuinely worth understanding isn't just the numbers themselves, impressive as they are, but the underlying pattern behind them. Because that same pattern tends to repeat itself across other industries and other moments in business history. A boring, unglamorous piece of infrastructure gets built to solve a practical problem. It turns out to be valuable to far more people than originally intended. Whoever builds it first at scale ends up with a durable advantage that's difficult for competitors to erode, not necessarily because their technology is unbeatable, but because the cost and risk of switching away from an established provider becomes high enough that most customers simply don't bother. Over time, that durable advantage compounds, generating enormous profits that get reinvested into staying ahead of competitors and expanding into whatever the next major wave of demand turns out to be. Cloud computing followed exactly this pattern over the past 2 decades, and right now, we're watching that same pattern play out again, in real time with artificial intelligence. As the same three companies who won the first wave of this story position themselves to try and win the next one as well. Also worth sitting with just how quickly all of this happened, historically speaking. Less than 20 years ago, the idea of renting computing power on demand over the internet was a relatively obscure concept that most people, even most people working in technology, weren't seriously thinking about. Today, it's such a fundamental piece of how the entire global economy runs that it's genuinely difficult to name a major industry that doesn't depend on it in some way. Whether that's banking, healthcare, entertainment, retail, transportation, or education. Hospitals use cloud infrastructure to store and analyze patient data. Banks use it to process transactions and detect fraud. Airlines use it to manage bookings and flight operations. Government agencies use it to deliver public services. Independent creators and small business owners use it every single day without even realizing it. Every time they use a website builder, an email marketing tool, or a simple app that happens to be quietly running on top of one of these massive cloud platforms behind the scenes. This is really the quiet, underappreciated magnitude of what these three companies built, infrastructure so deeply woven into the fabric of the modern economy that most of us interact with it dozens of times a day without ever thinking about it. The same way most people don't think about the electrical grid until the lights go out. And that's really the most important thing to take away from all of this. The next time you hear a headline about one of these companies announcing another massive investment into new data centers, or spending an eye-watering amount of money on new AI chips, you'll understand exactly what's actually happening underneath that headline. It's not just a company throwing money at a trend because everyone else is doing it. It's the latest chapter of a business model that's already proven itself to be one of the most durable, profitable engines in modern technology, a model built on scale, on stickiness, on being the invisible layer underneath everything else, and now being extended into what might be the single biggest technological shift of this generation. Whether or not every dollar of this current wave of investment ends up paying off exactly as planned, the underlying logic behind why these companies keep betting bigger and bigger on this business is at this point very well understood and very hard to argue with.